Hello, what's up guys? Welcome to this fifth tutorial on PCB design in Eagle. In my previous tutorial I have explained you how to design a basic layout for a simple circuit, and this can be even built up to more complex and complex circuits. One of the examples will be doing it after this tutorial, that is in the sixth tutorial. Till now we had been using the libraries which were predefined by Eagle, but what if we want X component and that X component is not present in the Eagle library? In that case, we would certainly want to create our own library, and we want to use that particular component. As I said in my first tutorial, there may not be all the libraries present in Eagle, because there are thousands and thousands of components in market, and electronics is developing rapidly. So every day maybe one or two components or maybe hundreds of components are and getting developed. So it's very difficult for us a small software to keep track of all the components. So we'll be discussing about how to develop those particular libraries. I have collected one basic component, which is a basic LED transmitter. So we'll be designing this particular module as a library so that it can be used in our design. So let us start with it. Now we used to use this Eagle folder or Eagle path in order to create our projects, but in order to create library we would not use this particular folder, but we'll go to file, we'll say new, we'll say library. So it will open up this window. Now this is the parent window which would be handling all your cross files. So for a library, what do you need? You need a component file, right? And you need a layout file, and finally you need to interconnect the component and layout. So first of all, we will be making the layout based component. So for that you need to click this. So by clicking this, this is basically a package. So the package library, it may be an SMD, that is surface mount, or DIP. Okay, so DIP as in the through hole component. So let's say this as the name of the component is HFBR LED. Let's say HFBR LED. Let's say okay. It says create new package, say yes. So this window opens. Now you can see here that the squares are quite big, okay, and if I go on creating wires, it will take long steps. Okay, if I want to stop in between this, it will not be possible. And what if my dimensions are very small? In that case I may be in trouble. So what I will do is I'll again go to this grid which we had used previously. Okay, I'll select I'll make this one also I'll write this as 0.01 as size. So in this way my grids will become very small. Now having done that, what you would do is you would create the outer dimension. Now generally I don't suggest people to make the exact component which looks like this, because these parts are what fancy parts, or these are not providing any sort of information to the PCB. These are the information which may be provided maybe in the real 3D diagram, but in a PCB it doesn't make any difference to use these parts. So we'll consider this as a square of dimension of 7.62 plus 2.54 plus 2.54, or you can say maybe, I think since they have not given this dimension over here, let us consider it as 1, because this diameter is 1 and this one looks almost similar. So we'll consider this as 1 and 1, right? So it becomes 7, 8, 9. Let's make a 9.62 by 7.62 based package. Okay, so we want to make 9.62 by 7.62. So one way is you can simply start from this cross point denotes the 0, so I can start from here, okay, and I can go till 9.62, right? So this is one of the way. 9.6, let's say 6. Okay, so this is the disadvantage that you will have to compromise with the minute distances if you are not so much accurate. Okay, so this dimension has to be 7.62. So I think I did some mistake. So this is these are the problems which you face when you make these lines manually. So basically you have to make this type of things. Then I would not prefer to make this manually, because if I make manually I may be making mistakes in points, but in case of smaller components even points do matter. So the other way is simply write a command. So this is the place where you can write command. So you can do your entire eagle with commands, but it is very difficult to do that, so generally we prefer to do lots of work manually. Okay, so in order to make that, we'll write wire space. So we want to start from 0 0, then it's 9.620. Okay, so 9.620. Next it's 7.62, or sorry, it would be 9.62, 7.62. Then next point is 7.0, 7.62, and lastly it should end at 0 0. So it created their box. So this box can be measured from here. So you can see this is exactly 7.62, and this one is exactly 7.62, and this one is 9.62. So 7.62 by 9.62. Now when the box is made, either you can make it an SMD component or a DIP component. So SMD component means it's a top. So if you remember, we told that top is shown as a red symbol, whereas bottom is shown as a pad symbol. So presently we'll be using this one because we want to make a DIP component which looks like this. So in this it has 4 holes over here and 2 holes for drilling over here, or 2 pads and 4 pads over here. So generally these pads should be made equidistance, and many times it is done with intuition. So let's make a round. So generally either you take a round or you take hexagon. I prefer hexagon because it looks pretty decent while routing the figure. I don't want a bigger drill, so I'll say a smaller one. So let's say more smaller you can do, or you can even see how much drill is required. That can be seen through the diameter if it has been given in the diagram. So it says 1 mm as the diameter, so I'll say 1. Okay, so it's pretty big, so we require 4. So is it 1 or it's okay? So 1 is the diameter, so 0.4. Basically this drill, I think they consider over here as the radius, that's why it looks very big. So we want 4 of them, so let's make that. Okay, and 2 of them over here. So once these files are made, so once this thing is completed, so basically what we have done is we have done these 4 parts, and now since we are done with these parts, we will be done with the basic routing. Now always remember that you are going to use this device in order to make the schematics, so always try to maintain a sequence. So just right click it, click name, you see P$1, okay, this one is P$2, P$3, 4, so this one is 6, and this one is 5. So we always go like this, so it's better to flip this one over here and this one over here. So I am not exactly accurate because I am just wanting to show you how to make it, but when you do actual designing, it is always recommended to do each and everything with exact values. Okay, so once this thing is done, let's write the name of the component. Let's say it's HFBR. Okay, so we'll keep it over here, so you can write it as T name, right? So this is done. Okay, now once this thing is done, you would want to show the starting point. Okay, so this is the starting point, so let's name it as so this is the starting point, so we want to show a dot over here. So we'll show a small dot which is white color, because we don't want green color, because green color would be having the metal areas. All right, so once this is done, we need to save it. So let's save it as HFBRLIB, or you can give it any name, that doesn't make any difference. So that's it. We'll be moving forward with its more advanced things in the next tutorial. Till then, keep practicing.